Okay, dear students, so today we'll be doing MCQs related to haloalkanes. Okay, we'll be doing MCQs. Okay, related to what? Haloalkanes. MCQs. Okay, so let us understand from here. So question number 1 is Hun's Dykers reaction is used to prepare what? Alkyl halide from A number. One is your sodium salt of carboxylic acid, that is your sodium salt of carboxylic acid. Next, B is your diazonium salt. Diazonium salt, right? Option number C is silver salt of carboxylic acid. Silver salt of carboxylic acid, right? And D number is, that is your alcohols. Okay, so we know this Borodin-Hun's-Dykers reaction is actually using silver salt of carboxylic acid, right? RC double bond O is the silver salt of carboxylic acid. It is reacted with the bromine, right? To give what? RBr actually plus CO2 plus AgBr, right? And in here we can also use chlorine but not iodine. Okay, so this method is used to prepare either chloride or bromide. Okay, not iodide. Are you getting it? So the next question that we are going to discuss is best reagent. Okay, the best reagent for converting an alcohol into corresponding halide, into what? Corresponding halide. So option number A is that is a PCl3. Option number B is SOCl2. Option number C is HCl ZnCl2. Option number D is your PCl5. Okay, so when we use this SOCl2 with ROH, right, when we used SOCl2, this gave what? RCl plus SO2 plus HCl. These two were your gaseous products, right? These two were your gaseous products, and this could be easily separated off from RCl process of distillation, right? So this is the best method to prepare alkyl halide from the alcohol. Okay, so now question number 3 is which of the following reagent cannot be used? Which of the following reagent cannot be used to prepare alkyl chloride, to prepare alkyl chloride, okay, from an alcohol. Alkyl chloride from an alcohol. So this is NaCl. The second option is SOCl2. The third option is Cl5. Fourth option is SCl, ZnCl, anhydrous ZnCl2. We know that this was Darzin's process used. This was used. PCl5 is also used. SOCl2 is also used. These all three are used. So this is the only one which is not being used to prepare alkyl halide from the alcohol. So this is the correct answer. So option number A is correct. Okay. So the next question. Okay. So the next question that we are going to discuss is the order of reactivities of methyl halides in the formation of Grignard reagent. Okay. The order of reactivity of methyl halide uh, in the formation of Grignard reagent. Okay, Grignard reagent. What is Grignard reagent? This is actually RMZX, right? So option number A is CS3I. Option number B is CS3PR, and option number C is your okay. Option number C is your CS3Cl. Okay. Actually, we have to make order. Okay. So, which of the following uh, will be reacting faster? So we know reactivity of alkyl halide Ri is more reactive than RBr. RBr is more reactive than RCl, right? This is how. So actually this is reacting, and this will be reacting so fast, right, with Mg. So if we have to write order, then CS3I, then CS3Br, and then CS3Cl. This is the order. Okay. Okay, next question. So the next question that we are going to discuss over here is alkyl halide is used as methylating agent. Which of the following alkyl halide is used as methylating agent, right? So option number A is C2H5Cl. Option number B is, that is your C6H5Cl. Option number C is CH3I. Option number D is C2H5Br. So we must know that I group, right, better living group, right, because size of I is much more higher, right? I has higher size, right? So bonding, weak bond will be formed by this I with the C, right? So I is the better living group over here in comparison to bromine and chlorine. So first of all, I minus is a better living group, then Br is the better living group, then chloride is the better living group, right? So if you are set that which is the best one, so this I will be removed here to form CH3 plus and I minus, right? So this can be used as methylating agent, right? So next question is, Grignard reagent is prepared by reaction between. Okay, Grignard reagent is prepared by reaction of which of the following? So option number A is your magnesium plus alkane, al- alkane. Option number B is, that is your magnesium plus alkyl halide, magnesium plus alkyl halide, and it is your zinc plus alkyl halide, zinc plus alkyl halide, or D number, that is your zinc plus alkyne, zinc plus alkyne. Okay, so actually we know that when we react Rx with Mg, then this will be forming your R MgX, and this is what your Grignard reagent is. Grignard reagent is, right? So actually magnesium when reacts with alkyl halide, this will produce Grignard reagent. Okay, so next question is, um, which of the following alkyl halide has maximum density? Which of the following alkyl halide has maximum density, right? So option number A is your C2H5I, B number is C2H5Cl, C number is C2H5Br, and D number is your C2H5C6H5Cl. Okay, so which of the following will have the, sorry, this is your, this option is your okay, C2S5F, C2S5F. Okay, which of the following has the maximum density? So we have already learned that BP and density is directly proportional to what? Molecular weight of halogen, if R is same, if R is same. Look over here, this is C to the, this is R, right? This R is same over here, this R is same over here. Now molecular weight of iodine will be greater than bromine, and it will be greater than chlorine, and it will be greater than fluorine, right? So technically if we have to arrange uh, uh, in order of density, then C2H5I will have more density than C2H5Br, then C2H5 what, Cl, and then C2H5F, right? So highest density will be with this one. Okay, next question. So the next question that we are going to discuss over here is okay, ethyl bromide, okay, given here, ethyl bromide, okay, reacts with ZnCu couple in presence of couple in presence of what? Ethyl alcohol, ethyl alcohol, right? So ethyl bromide. So option number A is your ethane. What will be produced? Ethane. Option number B, methane. Methane. Option number C is your butane, and option number D is your diethyl ether. Diethyl ether, right? So let us talk here. First of all, what happens when zinc reacts with ethanol? Ethanol, this will produce C2H5O whole 2 Zn plus nascent hydrogen, right? Now, when ethyl bromide, that is your ethyl bromide means what? C2H5Br, when reacts with nascent hydrogen, this will give C2H6 plus HBr, right? HBr. So this is actually for producing the nascent hydrogen, right? And this nascent hydrogen will reduce this one to the alkane. So this will be ethane will be the correct answer. Okay. So the next question that we're going to discuss over here is in above reaction, what will the product? So you are being given with CH3, CH2, CH2, Cl, and this is reacted with what? Alcoholic KOH to produce B, and then this is reacted with HBr to produce C, and then this is reacted with Na ether to produce D, okay, to produce D. So in above, so given now, after that what is said is in above sequence of reaction, in above sequence of a reaction, D is what? So option number A is actually hexane, it is saying hexane. Option number B is propane. Option number C is allyl bromide. Allyl bromide. And then option number D is your okay. Option number D is your 2,3 dimethyl butane. 2,3 dimethyl butane. Okay, let us see here. So how to solve such questions? Let's come here and try to solve. So we have been given with CH3, CH2, CH2, Cl, and then we are using alcoholic KOH, means what? There will be elimination reaction over here. So hydrogen will be removed from here and chlorine will be removed from here. So this will give you CH3CH double bond CH2. Now this is reacted with HBr. So Markovnikov's rule will be applied. This will give H plus and Br minus, right? So this is getting negative charge and this is positive charge. And now this Br will attack over here and then H will attack over here to produce CH3, CH, Br, and this is your CH3, right? And now this is reacted with what? Now this is reacted with, okay, now this one is reacted with Na ether. Na ether. So look here, how will this react? This is CS, right? This part is CS3, CS3, and this is your Br. There will be same molecule reacting from the other side as well. This is CS, right? There will be Br and there will be CS3 and CS3. Now what will happen? This Na, there will be 2 Na, that will be eating 2Br. Okay, so minus 2NaBr will happen, and then the result will be CH2. There will be actually your this is your CH. There will be CS3. This is your CS3 and CH3. Let us make carbon number 1, carbon number 2, carbon number 3, and carbon number 4. So what will be the name of this carbon? 2 comma 3. That this is one substituted group and this is one. Okay, there are two substitutions. So this is your 2 comma 3 dimethyl, and how many carbon is there in chain? That is your 4 carbon. So this is 2 comma 3 dimethyl butane. 2 comma 3 dimethyl butane. Let us go to the option. So option number D is the correct answer, right? That is your 2 comma 3 dimethyl butane. Okay, now let us come here. Okay, next question. And the question is, which of the following compound would be hydrolyzed most easily? Okay, which of the following compound will be hydrolyzed most easily? Which of the following compounds will be hydrolyzed most easily? Okay, so the options are, okay, let's see options. That is your C, this is your actually C2H5Br, C2H5I, C number is actually your C2H5F, D number is C2H5Cl. We know that which one is the better leaving group. I minus is better leaving group than Br minus, then okay, this is F. Okay, then Cl minus, then it is F minus, right? So when it is easily left, then actually the bond is broken, and hydrolysis, during hydrolysis this will be removed easily, right? So which is more readily hydrolyzed, most easily hydrolyzed? That is your C2H5I, right? After that, if we have to say, this is your first, then this one is your second, and then this one. Actually, this is the order of nucleophilic substitution reaction. Okay, nucleophilic substitution reaction order. This will be more reactive toward the nucleophilic substitution reaction, then this one, then this one, then this one. Okay, next question that we are going to discuss over here is, okay, there is question like 2 comma 2 dichloropropane on hydrolysis gives. Option number A is propanol. Option number B is ethanol. Option number C is 2,2 propanediol, 2,2 propanediol, and option number D is propanol. Okay, So let us solve this one. Look here, this is CS3, there will be Cl, this side also Cl, and this is your CS3. On hydrolysis of this one, this Cl will be replaced by OH, right? So this will be CH, OH, OH, and CS3. But this is actually unstable. Unstable. If there is two OH on the same carbon, then that is always unstable. So there will be removal of one water molecule from here, and this will give CH3C double bond O CH3, right? After removal of water molecule from here. So let's say after removal of water molecule from here, so this will give this one. This is actually your propanone, right? So next question is, the next question is actually, ethyl bromide reacts with lead alloy to form. Okay, there is ethyl bromide reacts with lead alloy to form. Okay, one is your option is your ethyl sodium, B is your ethene, C is your tetraethyl lead, and D is your ethane. So let us see here, when you react this one with lead alloy, suppose this one is the lead alloy, so this will produce C2H5 whole 4 Pb plus an ABr, and Pb will be precipitated. Okay, so look here, this is actually how many ethyl here? 4, so it is called tetraethyl, and this is your lead, so this is called tetraethyl lead, right? So this is TEL, tetraethyl lead. So option number C is the correct answer. So the next question here that we are going to discuss is, so addition of 1% chloroform act as 1% alcohol to chloroform act as. Okay, addition, you have to read, you have to by heart this one. Okay, addition of 1% alcohol to the chloroform acts as okay. Option number A, positive catalyst. Option number B, negative catalyst. Option number C, that is your ethanol. Let us see. Okay, auto catalyst. This is your auto catalyst, and option number D is your biocatalyst. You have to by heart this acts as negative catalyst. Why do we add 1% alcohol to the chloroform? So as to remove what? Phosgene gas, right? Phosgene gas, which is a poisonous gas, right? This is a poisonous gas, right? So what happens? Ethanol reacts with phosgene to form what? Diethyl, right? Carbonate, right? Diethyl carbonate. Okay. Next question. So chloroform on heating with zinc dust and water. Chloroform on heating with zinc dust and water produces. Okay, option number A is C2H2. Option number B is C2H4. Option number C is CH4. Option number D is your CH2Cl2. So you have to remember this will produce alkane. Okay, when we react this in the presence of ZnH2O, this will produce alkane. Are you getting it? Next, so next question is chloroform on reduction with zinc and HCl produces chloroform on reduction with zinc and HCl. So CHCl3, when you use zinc and HCl, this partially reduction will occur and this will produce CH2Cl2. When you react this with zinc and water, then it will directly give alkane. Okay, you have to by heart these two reactions. So next question is, which of the following is formed when iodoform is boiled with KOH? Which of the following will be formed when iodoform is boiled with what? KOH. So option number A is potassium. Option number B is potassium formate. Option number C is hydrogen, and option number D is iodine. So let us see, this is your iodoform. React this with KOH, then this will give HCOOK, which is your potassium formate, right? So the next question is, which of the following is formed when the chloroform reacts with chlorine? Okay, CHCl3, when reacted with chlorine, this gives CCl4, right? We have learned this in the haloalkane as well, right? Free radical mechanism in the presence of light, right? Okay, so what happens, which of the following is formed when sulfur monochloride is reacts with CH2? Okay, which of the following will be formed when sulfur monochloride is reacted with CS2, right? So option number A is CCl4. Option number B is S2Cl2. Option number C is Cl2, and option number D is S4Cl2, right? We know that when CS2 reacts with S2Cl2, this gives CCl4 plus sulfur, right? So this is the correct answer. So Cl4, Actually, this is the preparation of the carbon tetrachloride CCl4. Okay. So the next question that we are going to discuss over here is Westron is. Okay, you have to remember this. Westron is. What is Westron? We prepare from this one by reacting with 4 actually 2 chlorine. So this will give you CHCl2 and CHCl2. When you name it, this is carbon number 1, this is carbon number 2. So 1 comma 1 comma 2 comma 2 tetrachloroethane, right? Ethane. Okay. Next question that we are going to do is in the preparation of CHCl3 from ethanol, bleaching powder. In the preparation of CHCl3 from C2H5OH CaOCl2 acts as, you have to remember, it acts as both what, chlorinating and oxidizing agent. Both chlorinating and oxidizing agent. That's it for now. In next lecture we'll complete the rest of it.